Suppose root 29 it is there. Now it is clear. I is the nearest integer. I is the nearest integer. What is the nearest integer? Nearest integer is 5, because square root of 25 it is 5. I hope the idea it is clear. A minus I square. A is 29 minus I square divided by 2 into 5. So 5 plus 4 by 10. That is how the concept is derived. I hope this concept is extremely clear to you. How to find the approximate value of a non-perfect square with a proof. A is nothing but I plus E whole square. I is the nearest integer. A is the estimated approximate change. Square root of 31 is 5 point something. That something is nothing but A. A is a very smaller value. Because I require approximation, A is approximated to I square plus 2 into I into E. E is nothing but A minus I square by 2 into I. I hope the idea it is clear. I hope the idea it is clear. Now we will solve multiple problems. So what is the concept? Approximated value. Approximated value of a non-perfect square. Approximated value of a non-perfect square. If A is a non-perfect square, if A is a non-perfect square, A is a non-perfect square, I want root of A. I want root of A. If I want root of A, what will be the answer? Answer is nothing but I plus A minus I square divided by 2 into I. A plus I square divided by 2 into I. I is the nearest integer. Nearest integer just less than root of A. I is the nearest integer just less than root into A. I hope the concept is clear. For example, root of 43 it is there. Root of 43. What is the nearest integer just less than root A? Root 36 is less than root 43. Root 36 it is nothing but 6 plus 43 minus 6 square divided by 2 into 6, which is 6 plus 7 by 12. Approximately answer is 6, 7 by 12. Not a single video in YouTube channel all over the world you will get these proof. Second one, for example, root of 71. 71. What is the nearest integer just less than root 71? Root 64. 8 plus 71 minus 8 square divided by 2 into 8. I want my students to be different from others. When they are explaining my logics to their friends who has not seen any of my videos, they should say it with 100% conviction. Answer is 8, 7 by 16. Answer is 8, 7 by 16. How to find the approximate value of a non-perfect square? You can proceed it to a 3-digit number or a 4-digit number or a 5-digit number. Let me take, for example, 7754 it is there. 7754. It is not a perfect square because any perfect square is of the form 4k or 4k plus 1. It is 4 into 13 plus 2. 88 square is just less than 7754. 88 plus 7754. 88 square is 7744 divided by 2 into 7744. This will give you the 88 dot approximated value. I hope the class is concept is clear. How to find the approximate value of a non-perfect square? 2-digit number, 3-digit number, 4-digit number, and so on. Any digit number you can solve. I hope the idea it is clear. Next one, how to find the approximate value? How to find the approximate value of a non-perfect cube? Then slowly after 5 to 10 minutes, you will be able to solve any non-perfect nth powers. How to find the approximate value of a Non-perfect square we already did. Let us do non-perfect cube. How to find the approximate value of a non-perfect cube? First, some key points. First, see here. Perfect cube key points. Perfect cube key points. Then we will see when the numbers will not be perfect cubes. Perfect cube key points. Now listen carefully, sir. After 5 to 10 minutes, this concept will be very clear to you. What do you mean by digital sum? Digital sum is defined as the sum of the digits until a single digit is obtained. Digital sum is defined as sum of the digits until a single digit is defined. 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the possible digital sums of every number. What is a very important key point with respect to perfect cube? Now see here. 91 if I take, what is the sum of the digits? 9 plus 1, 10. 10 is nothing but 1. 181 digital sum is 1. 991 digital sum is 1. I am taking the set of all the numbers whose digital sum is 1. I am taking the set of all the numbers whose digital sum is 2. I am taking the set of all the numbers whose digital sum is 3. If I cube it, I will get a perfect cube. 1 cube it is 1. 2 cube it is 8. 3 cube it is 27. Digital sum is 9. 4 cube 64, digital sum is 1. 5 cube 125, digital sum is 8. 6 cube 216, digital sum is 9. 7 cube 343, digital sum is 1. 8 cube 512, digital sum is 8. 9 cube 729, digital sum is 9. Very, very important key point. If the number is a perfect cube, then the digital sum of that number will always be 1, 8 or 9. 1, 8 or 9. We will write down that point. Every perfect cube has a digital sum. Every perfect cube has a digital sum. 1, 8 or 9. 1, 8 or 9. Reverse may or may not be true. If a number is a perfect cube, then the digital sum of that number will always be 1, 8 or 9. Very, very important concept, so that you will understand how when the approximate value of a non-perfect cube you have to find, and when the direct answer you will get. If a number is a perfect cube, then the digital sum will always be 1, 8 or 9. 1, 8 or 9. If the number is a perfect cube, then the digital sum will always be 1, 8 or 9. Reverse case may or may not be true. If a number is a perfect cube, digital sum will always be 1, 8 or 9. We will write down that point. If the number is a perfect cube, then digital sum will always be 1, 8 or 9. Very, very important key point. Very, very important key point. For example, cube the root of 13. What is the digital sum of 13? Digital sum of 13, it is 4. If the number is a perfect cube, it should have digital sum 1, 8 or 9. So 13 is a non-perfect cube. 13 is a non-perfect cube. For example, cube the root of 65, it is there. What is the digital sum of 65? 6 plus 5, 11. 11 digital sum is nothing but 2. So 65, it is a non-perfect cube. How to find out the Value for a perfect cube, that is something which is very easy. You will get it in tons of videos. In case if you are watching my video, every class of mine, I will try to teach something new and innovative for you, so that it will also be a great learning happiness for you. So, first write down cube the root of n. Cube the root of n. If n is a perfect cube, if n is a perfect cube, output will be a natural number. Output will be a natural number. If n is a non-perfect cube, if n is a non-perfect cube, this value will be an approximated decimal. Same like what we did for a non-perfect square, same approach I will solve, so that you will understand how you will get the answer. If n is a perfect cube, then the output will be a natural number. If the n is a non-perfect cube, then I will get an approximated decimal. Then I will get an approximated decimal. Then I will get an approximated decimal. Very, very important slide. If the number is a perfect cube, the digital sum of that number will always be 1, 8 or 9. Wherever the digital sum is not 1, 8 or 9, how to find out the approximate value of a non-perfect cube? How to find the approximate value of a non-perfect cube? I hope this concept is clear. Same. Now, another beautiful concept. Same thing what we did. Watch the entire video. Then you can find out approximate value of a non-perfect nth power also. Non-perfect cube. How to find the approximate value of a non-perfect cube? Now see here. How to find the approximate value of a non-perfect cube? Cube the root of a, it is there. A is a non-perfect cube. A is a non-perfect cube. Non-perfect cube will have digital sum values anything other than 189. Anything other than 189. For example, cube the root of 13, it is there. It is greater than cube the root of 8. It is greater than cube the root of 8. Cube the root of 125, it is there. It is greater than cube the root of 64. It is 126 we will take. It is greater than 125. 126. 126. 126. 120, 125 is 5 cube. 126. This proves a point. Any number, if the digital sum is 1, 8 or 9, then the number may or may not be a perfect cube. So 126 is greater than. Same. If it is square, what I did square. I plus e whole cube. I plus e whole cube. What is I? I is a nearest integer. I is a nearest integer. Just less than cube the root of a. I is a nearest integer just less than cube the root of a. E is the estimated value. Estimated value. E is what we need to find out. E is the estimated value. Now see here. Now see. A is I plus e whole cube. A plus b whole cube. One is a cube. Next is 3a square b. Next is 3ab square. And next is b cube. Next is b cube. Now see here. Now listen carefully. These are nothing but estimated value. It is very small. Cube the root of 10 is 2 point something. These are all very small values. So I can approximate by taking first two values. I cube plus 3i square into e. So e is nothing but a minus I cube divided by 3 into I square. I hope the concept it is clear. E is nothing but a minus I cube divided by 3 into I square. Same thing I did. If it is a non-perfect square, I did I plus e whole square. If it is a perfect cube, I did a plus e power 3. A plus e power 3. So we will write down here. Then you will be able to understand everything. A is I plus E whole square. So this is nothing but A is approximated to A square plus 2 into I into E. E is nothing but A minus E square divided by 2 into I. Similarly, if it is a cube, I plus E whole cube, so A is approximated to E cube plus 3 into I square into E. So E is nothing but A minus I cube divided by 3 into I square. 3 into I square. Once you know the estimated values, then the logic will be extremely easy for you. Now, how to find out the cube root of 13? Cube root of 13 is greater than cube root of 8. So I want to cube the root of A. It is nothing but I plus E. E is nothing but A minus I cube divided by 3 into I square. Finish answer. I is nothing but cube the root of 8, it is 2. This is 13 minus 2 cube, it is 8 divided by 3 into 2 square. So answer for this question is 2 plus 13 minus 8 is 5. 4 3s are 12. Approximately 2 5 by 12, it is the answer. Approximately 2 5 by 12, this is the answer. Few more examples. Cube the root of 75, it is there. Cube the root of 75. Now, cube the root of 75 is greater than cube the root of 64. So, what will be the answer? It is 4 plus something. A is nothing but 75 minus 4 cube divided by 3 into 4 square. You will not find these in any of the regular textbook. 16 3s are 48. Answer is closer to 4 7 by 48. Answer is closer to 4 7 by 48. How to find the approximate value of a non-perfect square? How to find the approximate value of a non-perfect cube? Not a single doubt, you will get it in the class and you don't need to remember anything. Only thing is that because it is approximated, E square and E cube, they are all smaller values. I forgot. For this, what all teachers will do, who just refer one book and take a class very nicely without giving you the proof. In case if you are taking a class for an IIT student or an NIT student, definitely he or she is not going to appreciate you if you just write the formula. I hope the idea, it is clear. Now we will generalize it. A is equivalent to I plus E whole square. E is nothing but A minus I square divided by 2 into I. If it is a cube, how to find the approximate value of a perfect cube? It is nothing but how it is derived also I discussed. A minus I cube divided by 3 into I square. How to find the approximate value for a non-perfect fourth power? If it is fourth power, E is approximately. If it is square, I got square. If it is cube, I got cube. If it is fourth power, I power 4. I power 4 derivative, it is nothing but I cube derivative is 3I square. It is nothing but 4I cube. From where you got? A is nothing but A power 4 plus 4I cube A. And so on. These are all smaller values. I hope it is clear. Now please make a note of one important concept. Approximate value of a non-perfect nth power. Approximate value of a non-perfect nth power. This is the heading for today's class. Once you know this concept, these are all extremely important concept. It is nothing but A minus I power n divided by n into I power n minus 1. D is nothing but E. E is nothing but an estimated increase. E is nothing but an estimated increase. Nth root of A. A is nothing but the non-perfect nth power. A is nothing but the non-perfect nth power. I is nothing but the integer just less than nth root of A. Just less than nth root of A. I hope the concept is clear to you. So there is no absolutely formula based learning. These are all mandatory concepts a student should know. Now, not only for a non-perfect square, non-perfect cubes, you can also derive it for a 5th power, 4th power, 6th power, 7th power. This is the beauty of thematic based learning. This is the beauty of thematic based learning. Once you learn the concept for the first time, then everything will be extremely easy for you.